Hello. In this video, we want to look at example 5 for exam 3 review. The total profit P of X in thousands of dollars from a sale of X thousand units of a new product is given by P of X is equal to natural log of negative X cubed plus 6X squared plus 96X plus 1, where 0 is less than X is less than 10. Now notice that the domain is already given to us. We love it when that happens. A, find the number of units that should be sold in order to maximize the total profit. So if we want to maximize the profit, we want to find the relative extrema, technically the absolute extrema, in the interval from 0 to 10. So let's go ahead and find the derivative of this function. So P prim of X here, well, because this is a natural logarithm, we need to find the derivative of the natural logarithm. To do that, we're going to have a quotient, not the quotient rule, just a quotient. The denominator is the argument itself, negative X cubed plus 6X squared plus 96X plus 1. And in the numerator, it's the derivative of the argument. And that's going to give me negative 3X squared plus 12X plus 96. Good. Now, because it's natural log, I don't need another natural log in the denominator, so good. And there you go. That's the derivative. In order to solve this, we need to set both the numerator and denominator equal to 0. That gives me negative 3X squared plus 12X plus 96 equals 0. And notice that all these are divisible by 3, so I'm going to divide them all by 3. Negative 3, in fact. So X squared minus 4X minus, what is that? 32 equals 0. Anything multiplied to 32 and have a difference of 4? Yes, 8 and 4. So the factorization of this would be X plus 4 and X minus 8. That gives me X equals negative 4 and X equals positive 8. Good. Now, notice that negative 4 is not in our domain, so I don't need to worry about it. 8, however, is. So it is, in fact, a critical number. Then we need to look at this and set it equal to 0. So we have negative X cubed plus 6X squared plus 96X plus 1, set it equal to 0, and solve as well. Now, to solve that one, I'm just going to say go to the calculator and use it. So on y equals, on y1, we're going to type in the function, or not the function, the denominator, negative X cubed plus 6X squared plus 96X plus 1. Good. For the window, it's 0. No, it's not. Yeah, it's 0 to 10. Good. And if I graph this, I'm going to put this on zoom 0. Notice that it's not going to have any solution in 0 to 10 here, maybe over here. So let me change my window. Let's make that negative 2. And the y minimum, let's make that negative 10. Okay, so it does cross here. So I'm going to do second calc, the 0. I'm going to move this all the way over here to where I'm below the x-axis. Click enter. Go to where I'm above. Click enter and then enter again. And notice that it says negative 0.01. And so it actually never reaches 0 in 0 to 10 because that's a negative value. So there are no solutions in 0 to 10 here. So as a result, actually, I should just use a parentheses here. As a result, what that tells me is the only critical number that I have here is 8. And again, it's only because we've limited our domain specifically right here. Wonderful. So let's determine if x equals 8 is a maximum or a minimum, or neither. So we're going to start at 0 and then go all the way to the right to 10. So 0 to 10 here. And we have 8 in the middle. So we need test points. Let's say 1 and 9. And we're going to plug those into the derivative. Wonderful. Now, to do this, we're going to go back to the calculator, go to y equals. On y1, we're going to type in the original function, the natural log of negative x cubed plus 6x squared plus 96x plus 1. On y2, we're going to type in the derivative. And the numerator was negative 3x squared plus 12x plus 96. The denominator again was just negative x cubed plus 6x squared plus 96x plus 1. Good deal. And the window, of course, is 0 to 10. And if I do zoom 0, it makes it a little bit easier to see. Actually, let's make the maximum 20. There we go. So the blue is the original function. So notice that it's going up until that point, and then it starts going back down. So on the table here, the important point was 8, which means I need to look at 1 and 9. And again, we're looking at the derivative. So it's positive for 1 and negative for 9. So we're going to be going up until we reach 8 there, and then down between 8 and 10 there. So 8 is in fact a maximum, the absolute maximum in fact. So the number of units, so x equals 8 is a relative maximum. But notice that x is in 1,000 units. It wants to know the number of units, not the x value. So the number of units is 8,000 units, or in other words, 8,000 units. There we go. That will maximize the total profit. The question then becomes, what is the maximum profit? Well, to figure that out, we don't plug in 8,000 into here. We plug in x equals 8 into here for all the x's. In other words, let's look at 8 for x. Now, y1 is 6.463, right? And again, p of x is in thousands. So $1,000 here. So p of x is in thousands of dollars. Since p of 8 is equal to 6.463, that tells me that the maximum profit is $6,463, because you just take that and multiply by 1,000. Outstanding. And there you go. That is example 5 for review 3. Have fun.